Hello, Integrated Math 1. Welcome back to Boot Camp. Today's Boot Camp episode is brought to you by the coordinate plane. You guys have dealt with the coordinate plane before. Again, nothing we're doing here is new, but it's good to refresh, good to have that in your memory because it's going to be coming back to us this year. So we want to make sure that we're solid. So if you recall, a coordinate plane is made up of two number lines that intersect at 0, right? I've got a horizontal number line and a vertical number line, and they intersect at 0 right there in the middle. And we call that intersection of the number lines the origin. So this little guy, 0, where my two number lines meet up, is the origin. Now, my horizontal number line is also known as the x-axis, and it's positive when we go to the right of the origin, and of course it's negative when we go to the left of the origin, which makes sense because the origin's at 0. For our vertical number line, we know it as the y-axis, and of course, since 0 is sitting in the middle, that means it's positive above the origin and negative below the origin, so no surprises there. You know this. Also, a reminder that when we describe a point on the coordinate plane, we do so with what we call an ordered pair, with an x coordinate and a y coordinate. Please notice it's alphabetical. Our x coordinate, which is our side to side, our x-axis, right? That's our horizontal guy. Our x coordinate is always the first number, and our y coordinate, the up and down, is always our second number. And of course, we put parentheses around it and a little comma in the middle to keep everybody safe and tight. So the x coordinate describes the horizontal position of our point, the left and right of our point, right? That's how that goes, our side to side. And our y coordinate describes the vertical position of our point, the up and down. So I'm going to show you a quick example. Here I have a point right here. Do you see it? Did you get the point? There you go. Here's my lovely point. Now my first coordinate is x. That's my left or right. Well, if this is the origin, I'm going left 8. It looks like to get to this point, I have to go left 8 units. So my x coordinate is going to be a negative 8. But I also need to go up to get to this point. So from the origin, it looks like I have to go up. There it is. I have to go up 4 units. So that would be a positive 4 for my y coordinate. So I would say that the ordered pair for this point is at negative 8 because side to side is first. Our x coordinate is always first. And positive 4 would be our second coordinate because that's our y coordinate, our up and down. So I'd like you to just practice a few little things. For the first problem, I have a point here on the graph, and I would like you to give the coordinates of that point as an ordered pair. For the second problem, I've given you the ordered pair coordinates, and I would like you to plot that point on the graph, on the coordinate plane. So go ahead and hit pause to work these out. It won't take you long, and then hit play to keep going. So for this point, we want to give the coordinates, right? And it looks like we said x was first, so side to side is first. It looks like I had to go left 1, 2, 3 units to the left. Please note that's a 3, and since it was to the left, that means my x coordinate is going to be a negative 3. But it also looks like I had to go down from the origin. It looks like we went down 1, 2, 3, 4, 5, 6 units down to get to that point. So my y coordinate will be a negative 6. So 3 units to the left and then 6 units down. So negative 3, left is negative, and negative 6 because down is negative. For this one, we want to plot the point to negative 5 on our coordinate plane. So fine, if this is my origin, 0, I need to go positive 2, then negative 5. And we said, since that's a positive 2, hang on. Let me click the right buttons here. I want my pen. There it is. That means, since that's a positive 2, sorry for the weird writing, we're going to go right 2 units. And since that is a negative 5, my pen's all kinds of crazy today. Since that's a negative 5, we're going to go down 5 units. So don't forget the first one is side to side, and since it's positive, we'll go right 1, 2. And then our second one is up and down. That's a negative, so we're going to go down. So we're going to go right 2, down 5. So from the origin, 1, 2 to the right, and then 1, 2, 3, 4, 5 down. There it is. Make my lovely little point. Yay, you plotted your point. Good job. Now, this isn't new. You've done this before. There's no surprises here. So let's kick this up a notch. You've also learned that you can graph a line in slope-intercept form using this lovely formula here, y equals mx plus b. You've seen this before. It's not new. You're going to see some new versions of this as we go throughout our course this year, but this is the one you know and love. It's called slope-intercept form. And of course, it's called slope-intercept because it gives us a slope and an intercept. This letter b back here, it's a placeholder for a number. It's a variable for a number. Whatever that number b is, that's going to be our y-intercept. It's where it crosses our y-axis. And of course, m, and I don't know why we use an m. We just do. I'm going to have to look that up someday. M is our slope. And so that's why it's called slope-intercept form, because m is our slope and b is our y-intercept. So b is where it crosses the y-axis. M is our slope. And if you recall, slope is written as rise over run. We like to write it as a rational number. We like to write it as a fraction, a rational number. And our top number tells us up and down, and our run number tells us how far to the right we got to run. So just to do a quick demonstration, I have a line. I have a function here, a line that I would like to graph. Y equals 3 over 4x minus 6. So I'm going to take this apart a little bit. This guy on the end is where I start. That plus b, well, that's a minus 6. So that means my y-intercept is negative 6. So I'm going to make a start at the origin, and I'm going to go down to negative 6 on my y-axis. There it is. And there's my first point. Yay. Now, from my y-intercept, I'm going to use my slope. So I don't go back to the origin. I'm taking off from my y-intercept. I'm going to use my slope. Now, my slope is 3 over 4. Please remember that the x is not your slope. The x is just helping you find your slope. The x is sitting next to your slope, so you know where to find it. We'll also be calling it a rate of change as we go through this year's course. So here's my slope, my rate of change, 3 over 4. So this is rise over run. So I need to rise 3 and run 4. So from the y-intercept, I'm going to go up 3 units and then right 4 units. So from my y-intercept, I'm not going back to the origin. I'm going to rise 3, 1, 2, 3, and then I'm going to go right 4. 1, 2, 3, 4, and make another lovely dot there. And because this is just a straight line, you can now grab a straight edge and connect the dots to make the line. So we will connect the dots. La, 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 la. There it is. It does help if you use a straight edge. Please don't forget that since these are lines, there should be arrows on either end. That a line goes forever and ever in both directions. So make sure you put little arrows on the end of your lines. Make sure you use up as much of your graph as you can. Go to the edges of your graph, people. Go to the edges of your graph. So I have a whole bunch of these for you to practice. I should warn you, I've thrown a few tricks in to mess with you. Sorry, I'm mildly evil after all. So go ahead and hit pause to work these two out, see what you can do with them, and then hit play when you're ready to check your work. So I'm going to start with this guy. Y equals mx plus b. So it looks like my y-intercept is 2. So there's my y-intercept, and that's a 2. So I can find 2 on my graph. There it is. Now, the slope is where I'm having a little bit of trouble here because we said slope was rise over run. There's nothing underneath it. It's just a 5, right? It's just a 5. Do you remember what you can always put underneath a number to turn it into a fraction? What you can always put underneath a number to turn it into a fraction? That's right. You can put a 1 under it. Oh, I just did that. So my y-intercept is a positive 2. I will make my point at 2. My slope is now 5 over 1. So I'm going to rise 5 and run 1. You have to have a denominator. It's rise over run. You've got to have something on the bottom. If there's nothing on the bottom, put a 1 under it. So I did. So I'm going to, from my y-intercept, I'm going to rise 5, 1, 2, 3, 4, 5, and then I'm going to run 1 and put another dot and connect them up. Yay. For this lovely guy, it's a little bit easier to work with, but I can see I have a y-intercept at 4. I can see my slope. Ooh, my slope is a negative 2/5. So here's what I'm going to do. There's only one negative sign. So I'm going to assign the negative sign to the top. So this means my y-intercept is a positive 4. So there's positive 4 on my y-axis. Make a dot. And from here, my rise over run is negative 2 over 5. So I'm not going to go up 2. I'm going to go down 2. But I'm still going to run 5 to the right. So that negative says I need to go down 2, 1, 2. And then I'm going to run 5 to the right. 1, 2, 3, 4, 5. Make my other dot and connect them up. Yeah. That wasn't so bad. That wasn't so bad. You know you can put 1s underneath your slopes to turn them into fractions and to get that run. You know negatives just mean you go down instead of up. There's nothing shocking here. But I got to mess with you. I got to mess with you just a little bit more. Can I mess with you just a little bit more? Just a little. Last ones, I promise. Go ahead and see what you can do with these. Hit pause to try these out. And then hit play when you're ready to check your work. All right. You ready? I'm looking at this guy. I can see that my y-intercept is a negative 7. Hooray. Uh-oh. My x is naked. Slope, slope, slope. I need a slope. All right. Don't panic. There is a slope. There is a slope. Okay. So don't panic too much. There is a slope here. And I can already see there's a typo coming up. So my bad, guys. Here's my lovely slope. If you don't see anything in front of a variable, if your variable is naked like that, do you remember that you can always put, a 1 in front of it? Boo. Oh, sorry. My handwriting is not working so well with my little guy here. Let me fix that. Let me erase it. There we go. Pew. So you can always put a 1 in front of it. And of course, we want rise over run, so you might want to put another 1 underneath it. Oh, 1 over 1 is my slope. Sorry for the typo. That should say that shouldn't say 1, right? That should say a negative 7 for my y-intercept. My bad. So my y-intercept is negative 7. There's my first dot. And from here, I'm going to rise 1, then run 1. So up 1, over 1, make my second dot, and use a nice straight edge to connect the dots. This guy, oh my gosh. Well, okay, so some of the tricks you know you can put a 1 in front of that x. So it looks like your slope is negative 1 over 1. But there's nothing on the end. If you're missing your y-intercept, don't panic. Are you ready? I could always write +0. Okay, so it's weird to write +0. I get that. But do you know what your y-intercept is now? That's right. Your y-intercept is 0, and your slope is negative 1 over 1. So my y-intercept is 0. I guess on my y-axis, I'll put a dot right there. And my slope is negative 1 over 1. So I'm going to go down 1 and then over 1 and connect the dots. So I did have a few tricks for you today. Sorry. I got to mess with you a little bit. But I hope you found this helpful and useful. Of course, if you have questions or concerns, let me know. Email me. Come see me during office hours. Come talk to me. Let's get you sorted out. And I'll see you guys in a little bit.